Hi everyone. For those of you who I haven't met, my name is Ajaz. I'm a longtime resident of Chicago, and I now live and work in Colorado. I'm a mobile developer, iOS and slowly starting Android mobile developer at Gogo Business Aviation. We provide internet access on private jets, and I'm told that this is what the inside of a private jet looks like. Never been in one, so it must be nice. We've been around for about 25 years, and we also have a location in Chicago. I want to thank Apple for allowing us to meet here today, and I am looking forward to attending in person someday. And let's get started. When I was trying to decide on a title for today's talk, I went through a few different options, and I had to eliminate some of them. This was version number 1, was too verbose. And this was accurate, but it's not really, nothing memorable. So I finally decided on, well, actually. The model view controller design pattern is widely regarded as inadequate. People claim that this design pattern leads to massive view controllers or monolithic view controllers. They claim that it leads to messy code, that it leads to tight coupling between view controllers, and also that testing is really difficult with the model view controller. So we try other things. There are many different alternatives. We've got MVVM, we've got MVP, we've got Viper, and a whole bunch more. We try all of these only to replace one set of problems with another set of problems. They never seem to hit the spot. So we have to ask, what is it that we're really looking for in a good architecture? What we're really looking for is a distribution of responsibilities, easy testing, that's important, easy adoption of the design pattern. If it's not easy to adopt, it's not going to be adopted. Low maintenance cost, that's always nice. We want something that's difficult to abuse. And this is actually really important because the more I think about it, the more I realize that good architecture requires discipline. It's not like good coding practices that we can adopt when we're using a language like Swift, for example, or we can tell, like, last year Ellen had given a talk about not using Swift stringly typed code. Good architecture and good design patterns cannot be enforced by the preprocessor or by our compiler. We have to have discipline to use it. I have not yet seen any architecture, any good architecture, that cannot be subverted by either ignorance or malice or just plain laziness. That's the thing. We've got human beings who need to be motivated to actually use this. If they don't want to use the architecture, it's not going to happen. What does all of this have to do with MVC? Again, the more I think about it, the more I realize that it's not really a problem for MVC per se, but it's how we interpret it. Now, when I started preparing for this talk, I Googled Apple's definition of MVC, and I came to this Cocoa Core Competencies page. The very first sentence says, model view controller design pattern assigns objects in an application one of 3 roles, model view controller. Now, I don't believe that what Apple's trying to tell us is that every class in your app has to be one of these 3. What about, let's say, NS predicate? Is an NS predicate a model? Is it a view? Is it a controller? It doesn't make sense. So what I think is that what Apple's telling us is that an object does not have to be one of these 3, but it can serve a model, a view, or a controller. If we expand the definition a little bit, like everything else, like we're doing today with dub invitations, we have to read the tea leaves, read in between the lines what Apple is trying to tell us. And I think that's really what I understand from the model view controller architecture. It's not that every object has to be one, but every object can serve a model, or can serve a view, or can serve a controller. Now, you might not agree with me. And, my response to this is my favorite Polish saying, not my circus, not my monkeys. Uncle Ajaz don't care. At this point in my life, all I want is I just want to write good code. And also maybe, take a nap would be nice. I want to get on with my life I want to write code and get on with my life. I don't want to go all medieval theologian wondering how many developers can dance on the head of a pin. These discussions help. Yeah. Oh, I've got 2 copies of this slide. I've got 3 copies of the slide. Yeah, these discussions help the pundits busy while the rest of us work. But there are some things that I think we all can agree upon. A view controller shouldn't get massive. It's just a nightmare to maintain. A view controller shouldn't contain business logic. That's really not the place for business logic. Oh, before I continue, I forgot to say, if anyone has any questions, please feel free to interrupt. I might need Bob to repeat the question, but feel free to interrupt if you have any questions. A view controller should not have to manage an entire screen. Now, this is something that I didn't realize when I first started writing iOS apps. We read very often that a view controller is responsible for a screen that is displayed on your phone. Now, I've seen some pretty complicated apps where if I try to shove everything that I see on a screen in one view controller, it's going to get really messy. There's no way around it. There's a lot happening. So we'll see ways of having a view controller be responsible for just logical parts of a screen. So this is kind of important. A view controller shouldn't have to manage an entire screen. Testing should be painless because we all know if testing isn't painless, it ain't going to happen. So my advice is don't fight the platform. Apple has given us an environment. It's given us a whole, what's the word? It's given us an entire workflow. It's given us an entire environment to work with. The more we accept what Apple has given us, the less code we'll have to write. And the easier it will be to write that code that we do write. What are examples of what Apple's given us? Let's say auto layout. At this point, we should not be reinventing auto layout. Zibs, storyboards, we have them. Let's use them. And this is a very important point. I'm going to come back to this a little bit later in the talk, but we should use storyboards as glorified zibs, but not for the flow, not for the navigational flow of the application. And I'll show you why in a little bit. Apple's given us the responder chain. We should be aware of it and we should use it. And finally, we've got things like MVC. We've got design patterns. There are many other design patterns that Apple's given us, target view, etc. But it's given us a lot of these things that we should work with because it'll make our lives as users of their frameworks easier. One of the things that I've noticed is that a view controller usually has 2 responsibilities. At least in my old code, it had 2 responsibilities. It used to manage the views that are displayed on the screen, and it would manage the navigational flow. It would say that, once you tap on this button, you go to this view controller. You tap on that button, you pop another view controller onto your stack. But now I've begun to realize that we should not do both of these things in a single view controller. Why? Because it violates the single responsibility principle. And the other thing that it does that's even worse than just violating an abstractly named principle is that once you have a view controller managing the navigation flow of another view controller, these 2 view controllers become tightly coupled and they cannot be used independent of each other. And that becomes a problem. In a clean architecture, what we should do is avoid segues unless they're absolutely necessary. Like maybe we're doing custom segues or unwind segues, or maybe we're using embed segues. Segues make view controllers tightly coupled to each other because the navigation flow is it has to be in the view controller, and you can only access it in Prepare for Segue. Here's an example of a bad storyboard. Let's say, and this storyboard uses segues for navigation. You can see that there's a whole bunch of view controllers, a whole bunch of segues in this app. And if you squint really hard, you can see that there are storyboard references as well. Let's say we want to take this storyboard that's colored red, and we want this view controller that's colored red, and we want to move it to some other app. Excuse me. We can't just copy and paste the code and copy and paste the scene into a storyboard in the other app. We can't do that because of these segues. This view controller in red is very tightly coupled with this view controller. It's also very tightly coupled with this one. And then we also have to look at the incoming segues. This view controller, the first one that I showed you, is probably also tightly coupled with this one, which feeds it, and also this one, which feeds it. So now we have this issue. We've got all of these dependencies, and all we wanted to do is copy and paste something that we thought was isolated. Can't do it. In a clean architecture, view controllers should only manage views. They should manage the life cycle, they should communicate with views, and maybe manage a logical set of views as opposed to an entire screen full of views. Excuse me, sorry. View controllers should not have to manage, or they should not have navigation flow code, because navigation flow can be done outside of a view controller. It's better this way, because if you have the navigation flow code outside of a view controller, it prevents view controllers from being coupled to each other like we saw in the storyboard. It makes them more reusable. View controllers should not have business logic. They shouldn't have networking code, and they definitely shouldn't have UI table view data source and UI table view delegate code. That's like the easiest way to reduce code bloat in your view controller. And something else, okay, view controllers they have enough to do. Everything else that's not what we spoke about in this slide, everything else should be delegated to another object. And that other object is what I'm going to call the coordinator. As far as I can tell, this term was first used by Sarush Kanlu, but the idea has been around for a little while. It's been called different things, application coordinator or other things. Now you may say that, well, if you say that you're going to delegate all of the view controller's responsibilities to a coordinator, you might ask, aren't you just describing the MVP pattern, the model view presenter pattern? And my response to that will be, well, he said, but hold on. You can't just redefine MVC to suit your needs just so that you can go on with this talk. No, really, MVC has, I don't care. Even Apple's official documentation, when you Google a little bit more and go past the first slide or the first Google result, even Apple's documentations leave the definition of what a model is, what a view is, and what a view controller is open to interpretation. In fact, the MVP model says that the view controller is part of the view and a controller is something else. So there's a lot of, all of this stuff is open to definition, and we can argue till we're blue in the face, but we just want to write good code. So I'm going to show you how this coordinator works with the model view controller architecture with a sample app. The app's over here, and pretty much everything that you need is on this in this repo in GitHub. And it's a very simple app. It looks like this. It uses a UI split view controller, and it's a conference app. You may have seen me demo this app before. Here's a little demo of the app. Is it working? There we go. So you've got a UI table view, and you can look at the session detail, and you can drill down to bio detail. You can see the Twitter handle and the URL of the speaker. Same thing, you go back to your master view controller, your detail view controller, tap on the bio, you get the Twitter handle and the URL. And that's about it. That's all that this app does. So there are two ways to write this app. The wrong way, which is the way I learned when I was learning iOS development, and the right way. So let's look at the wrong way to do this. So in the repo, the wrong way is in the master branch. So if you want to compare, if you check out the master branch, that's the wrong way of doing it. So I'm just going to go through this really quickly because I don't want to spend too much time on the wrong way of doing things. What we're looking at over here is our master view controller, which is a UI table view controller. You've got some view model data. There's an array of objects, and you've got another array of session time slots that allows us to view our data according to a table view section, because you have arrays of arrays when you have table view sections and rows. Nothing really fancy over there. Got a view did load function. There's some view related code there. It calls super view did load. It does something with the table view. And then you've got some network code in the view controller as well. It'll on view will appear, it'll query the network, and it'll refresh when you have new data. There's also a method called refresh that is responsible for computing the contents of the view model of the data structures that we saw a couple of slides ago. So the responsibility for computing the contents of these data structures is in the view controller. What that means is we can't reuse this code without changing the view controller, without changing the view controller, or without taking the view controller. We can't have one without the other. And then moving down the file, we've got this. If you use mark to organize your code, you're doing it wrong. Right? The purpose of mark is not to organize your code. We should be using proper classes. Here we've got prepare for segue. And you can see that in prepare for segue, we're getting the destination view controller. So we're responsible for knowing what the next view controller in the sequence is, which immediately tells us that we cannot use this view controller in another app because we're going to have to change this code. These two view controllers now, the current one, the master view controller, and the destination view controller, the destination of the segue, they're like penguins now. They're mated for life. Okay, let's move along. Got some more marks. Again, we've got more intimate knowledge of the view models. We've went for a number of sections number of sections in table view and number of rows in section. We can't implement these functions without knowing everything about our model. And then we've got tight coupling as well between the view controller and the actual cells in the cell for row at index path. There's quite a lot of table view code over here. It's about 120 lines of code. Obviously, I'm not gonna go over it in great detail because this is pretty standard. In fact, if you look at most tutorials, probably even Apple's own documentation, they kind of show you this way of doing it. And then we just take it and we build upon it, and before we know it, we have a huge view controller. We have a detailed view controller as well. Let's have a look at that. It's pretty much more of the same. We have some flow code in prepare for segue. We've got a destination view controller, which in this case is a speaker bio view controller. We've got display code as well in the view controller. Obviously, we got to configure our views. We set the text of our different UI labels. We set the image in our UI images. So there's a lot of display code here. And then we have a third view controller called the speaker bio view controller. It's pretty much the same. I'm not going to go over that at all. It's all there in the repo. But I'm skimming through this a lot because it's all, this is the wrong way of doing the code. So let's look at the way that I call MVCC, which is really model view controller with a coordinator. Before we look at this code, we need to keep a couple of things in mind. The first is that the view controller in this pattern, the view controller is dumb. It has no business logic. It's easy to explain if you look at a little sequence diagram of how messages are sent from one object to another. So here we have, on the left-hand side, we have our user, which is us, the human being. The user taps a control, and essentially what's happening is there's an event that's being generated upon a UI view. The event goes up the responder chain. Eventually, the view controller is made aware that there's an event that I need to respond to through an IB action. Because the view controller is dumb, with this model view controller coordinator pattern, because the view controller is dumb, it's not going to handle anything in the IB action. It's just going to go, hey, coordinator, I got an event. Someone tapped this button. What should I do with it? The coordinator says, okay, let me have a look. It'll do whatever it needs to do, and then it will send a response back, or it'll send a message back to the view controller saying, hey, you need to update any visible artifacts that that communicate blah, blah, blah to the user. It doesn't really have references to the actual views, but it tells the view controller what the view controller needs to do. The view controller then says, oh, I know that what you're really telling me to do is update this view like this. And that's that last arrow. It'll update the view based on the information that the coordinator is sending back to it. Any questions so far? Okay. You guys can still hear me, right?
Yeah.
Okay, good. All right, so let's look at a coordinator. What does a coordinator look like? This is the entire coordinator class. It's not very complicated. At least this is a minimal coordinator class. So we've got a method. I prefer having a method to attach a view controller to a coordinator. So that's just, it's just a helper method. And then, because view controllers have these really nice hooks into the view lifecycle that we can take advantage of, such as view did load, view will appear, view did appear. I like to have those hooks in my coordinators as well, so they can take advantage of the lifecycle of the view controller. The view controller could optionally call them, because what happens in view did load, we know that our outlets are no longer nil, so we can take advantage of that. So if we want, we can have a view controller's view did load call the coordinator's view did load. By default, we have default implementations of these methods that don't do anything. They're just no ops. So let's see how this works. We'll take a little more time looking at this example. So now we have a new master view controller. In this master view controller, we have a coordinator. The view controller has a strong reference to a coordinator to which it delegates these messages. So look at view did load. View did load calls super.viewDidLoad, like we always do. And now it says, oh, hey, coordinator, let's call your viewDidLoad in case you want to do something now that we have our IB outlets defined. What I do is I'll set up my data sources and my delegates, the business logic essentially, in my coordinator's viewDidLoad. The view controller also does the same thing on viewDidAppear, or view will appear. It'll call view will appear on the coordinator. And we could add more as well, view did disappear, et cetera, et cetera. But this is all code that's copied and pasted from the GitHub repo. Now, the way I wrote this app is I used Apple's template for UI split view controllers. And Apple's template for UI split view controllers uses embed segues. So we'll see that in a second over here. So don't use segues unless you must. If we weren't using segues, the following code would not be here. But we are, because we're using embed segues. So we've got prepare for segue. And prepare for segue in our view controller says, first what it does is it gets the destination view controller, which is what we always do. It gets the section and the row of the cell that was tapped, the index path for selected row. And then because we already have a destination view controller, because the storyboard instantiated this view controller for us, we pass the view controller to the coordinator. So the coordinator knows what view controller it's responsible for. I don't like the fact that we have a destination here, but that's what we get when we're using segues. And now let's look at the coordinator for the master view controller. I call it the master coordinator. It's an NS object. It's nothing special. It doesn't have, there's no magical code that's running behind the scenes. It implements the coordinator protocol. It's got a weak reference back to its view controller, so we don't have any memory leaks. I create instances of my data source and my UI table view data source and my UI table view delegate. Notice what I'm not doing is taking my UI table view data source and delegate code and just throwing it in here, because then I'm just passing the buck on from a massive view controller to a massive coordinator. So I'm also making them separate objects. That's a good thing to do even if you're not using a coordinator. In view will appear, I'll query the network for data. I'll call get data, and get data will do what the view controller used to do before. And in view did load, now that I have my IB outlets in view did load, I'll say my view controllers .tableview.data source equals my data source, and I'll set my delegate as well, or the delegate for the table view, I should say. And sometimes, at least in this case, the delegate needs to know about the data source as well, so I'll make a link between the two. So what's interesting over here is that all of this code has moved away from the view controller to the coordinator. Now let's look at flow control. In our master view controller, we have a sub coordinator for our session screen or our detail coordinator. So just like we used to have view controllers that knew about other view controllers, we have to mimic that hierarchy with coordinators, because my master coordinator needs to know about my session coordinator. So I'll have an object of type session coordinator or my detail view controller. And in handle row selected, which is the method that was called from prepare for segue, in that method, since we're using segues, it gets a little ugly over here, but the destination view controller already exists. So what I'm gonna do here is I'm gonna attach this coordinator, the session coordinator, to my view controller, to my destination view controller. And I'll set the model object for that coordinator. So I'm just doing the housekeeping over here in handled row selected. Remember, handled row selected is called by prepare for segue. Normally, all of this would be done in the view controller. We're adding one more level of abstraction. Now, this may seem like a lot of work for no real gain, but there is actually a huge gain, and we'll get to that in a second. So this is the new way of creating our master controller. The entire view controller, you don't need to read this, but the entire view controller is about 56 lines of code. It's pretty clear, it's pretty straightforward. And the nice thing is, as we add more controls or more views, it doesn't drastically increase the size of the view controller. And this is 56 lines, including comments. Okay? All it's really doing is passing the buck on to the coordinator. Now let's look at our detail view controller, the one that had the detail of the session. Let's look at that. What we're doing over here in our detail view controller is pretty much the same thing that we did in the master. We delegate work to the coordinator. We have a coordinator called session coordinator, and in view.load, we call super.view.load, and we call coordinator.view.load. Pretty straightforward. Nothing fancy going on there. Here we have an IB action. And this is an example of that image that I had shown you. Someone tapped on the bio button, and the view controller says, hey, someone tapped on the bio button. I have no idea what to do. I'm going to ask the coordinator to handle this button tap. And that's what it does. It calls the handle button tapped method on its coordinator. And what does our coordinator look like? Well, first of all, it's pretty similar to the master coordinator. It's got a few exceptions, obviously. We've got to have our model data because we're displaying a session. We have to have a session object. Now, what's important to note over here is that this model data, the session object, was not set by the previous view controller, but it was set by the previous coordinator. The coordinators are passing data down the hierarchy. It's not the view controllers. Again, it may seem like we're just adding one more level of abstraction, but there's actually a tangible benefit to doing this. We have a sub-coordinator because from our detail, we can go to the speaker bio. So we have to have a sub-coordinator for our speaker bio. And the flow looks like this. The view controller delegates responsibility, like we said, for the button tap to this method, handle button tap. What handle button tap does, it says, okay, I know that I have a view controller called speaker bio view controller that's in this storyboard. I'm going to instantiate the destination view controller. Now, this is the way I like to do things, where the coordinator is responsible for the view controller. So I like that. And the coordinator is responsible for initializing the view controller, for creating it. So the coordinator creates the destination view controller. It pushes it onto the navigation stack. And then finally does a little bit of housekeeping. It attaches the destination view controller to the coordinator, and it passes the session data, the speaker data. You remember this detailed session coordinator had the entire session object, but the bio doesn't need to know the session object. The bio only needs to know the speaker object. So we don't take all of the data. We just pass the required data down the coordinator chain. We've got some, in our coordinator, we've got some view code as well. When we tell the view controller to render the appropriate views, look at what we have to do. We've got 4 different UI labels in there. And the coordinator doesn't know what those UI labels are called. It just has to tell the view controller, hey, populate the session name, populate the session description, populate the speaker name, populate the session image. So you see what's happened over here is we've got 4 methods for 4 different things, 4 different views. Now 4 is a small number. And these methods on the view controller look like this. We've got populate session image. I'm sorry, here, where is it here? Sorry, I went back a little bit. Hit the wrong button. Yeah, here we go. We've got populate session image. We've got populate session name. So this is all in the view controller. Populate session description, populate session speaker name. What we're doing is we're taking these higher level methods and translating that to what the actual views should be. But we have a small problem here when we have tons of views in our view controller. If we have a lot of views, populating them this way leads to a massive view controller problem and a massive coordinate problem. So there's nothing we can do about it. If we need a lot of code, we need a lot of code. But we would like to keep our view controllers and our coordinators modular. So the way we can do that is by using UI view controller containment. What that does is that each contained view controller gets its own coordinator. And they're no longer massive in the sense that they don't have a lot of code. Each contained view controller is responsible just for one subset of the views. Any questions on that? No. You guys can still, you can still hear me, right?
Yes.
Excellent. When we're using UI view controller containment, we wind up getting embed segues. They're a necessary evil because we're using containment. So we come back to the situation where our view controller kind of has to know about some other view controllers. But that makes sense in this case because they're embed segues. Yes, we're constructing a view controller out of smaller view controllers. So it makes sense that we should know about what these smaller view controllers are. So we're not really introducing coupling where there shouldn't be. The strategy with embed segues is the same as it was with segues from storyboards. We look at a segue, we look at a segue identifier, say, okay, if this is an embed image segue, then I know my destination view controller is going to be an image view controller, and I'm going to call register image view controller. If it's an embed labels, I'm going to call register labels view controller. What is these register functions? We'll see that in a second. The coordinator for this speaker bio has its own sub-coordinators for these embedded view controllers. So just like we have a view controller hierarchy, we have a coordinator hierarchy. So if view controller A contains view controllers B and C, the coordinator for view controller A needs to contain the coordinators for view controllers B and view controller C. Here we have our speaker bio coordinator, and it contains the 2 sub-coordinators, the image coordinator and the speaker labels coordinator. This is a direct result of us using view controller containment. That's why we have these 2 over here. Even though you can't click anywhere through once you're at the bio view controller, that's the last view controller. But because we have sub view controllers, we need sub coordinators. These sub-coordinators get relevant data when they're registered. The register image view controller just says, okay, I'm going to attach a coordinator to a view controller, and I'm going to take the little piece of information that I need. I don't need the entire speaker object. I just need the image of that speaker. I'm going to send just the image of the speaker to this coordinator. Register labels does the same thing. It says, I don't need to know everything about the speaker. I just need to know the speaker's name their Twitter handle, and their website. So I'm going to take these pieces of information out of my speaker object, which is my own model data, and I'm going to pass them on to my sub-coordinator. So this creates a cascading of model data. We had a session, and from the session we got, is there a question?
Yeah.
Okay.
When you something, are you passing a reference to the view controller?
I think the question is, when are we passing a reference to a view controller?
Yeah.
Yeah, yes we are. So the way I have these references set up is that a view, I think of it in the terms of that diagram that I'd shown you several slides ago, where you have a user, and then you have a view, and then you have a view controller, and you have a coordinator, right? So the way I see it is that the view controller should have a strong reference to the coordinator, and the coordinator has a weak reference back to the view controller. And then everywhere else, we're passing references to the objects as we drill further down into the app. Does that answer your question?
Yes, thank you.
You're welcome. Okay, so we're cascading the model data. We started off with a session, and then from the session, we extracted the speaker, and we sent just the speaker to the coordinator. And then from the speaker, we extracted just the image and sent it to its sub-coordinator. And from there, we extracted just the labels, and we said that. So we've got this cascading effect drilling down. In the case of this app, it doesn't always work this way, but this is a nice hierarchical app. So we've got, we take the components of our model data and set them as model objects for the sub-coordinators. We already spoke about that. And the entire speaker bio view controller is pretty straightforward because we're using containment. It's about 57 lines of code. And the entire coordinator is actually pretty small as well. It's about 49 lines of code. Again, because we're using containment, we don't have everything shoved into this one coordinator. We've not delegated, but we've factored out some of the stuff into other coordinators. So that's nice, right? Clean code is great. It's its own reward. But there's another huge benefit, and that is testing. And this is where we see the benefits of adding one more level of indirection. Let's say I want to write tests, unit tests, to test that given certain network data, I want to test that all of the speaker's Twitter handles are correct. Now, the old way would be like this. You don't need to read this code, but just see that the old way would be using UI automation. I'd run the app, and I have XCT asserts or XTC asserts. I can never figure out which one it is, but I'm going to speed it up a little bit. But we're going through the entire app, every speaker, going all the way down, and asserting that that the Twitter handle is correct. We've got a lot going on over here. This is a sped up video, and then we're finally done, and then all our tests complete successfully. Great. How long did that take? I'd like to know. So I'm going to go back over here in Xcode, click on the test inspector, expand this, and have a look at that. 86 seconds. So it took 86 seconds to test this. Now, because we are using coordinators, I don't need any view controllers. So what I can do in my unit tests, I have an app delegate. I have a master coordinator in that app delegate. I can just pretend I tapped row 0 in section 1, and then I can pretend I tapped the handle bio tapped button, and then I assert that the handle is myconf1. I can go back and I can pretend I tapped row 0 in section 3, and so on and so forth. I'm just pretending to do all of this stuff, and testing it the new way looks like this. The same tests. It's compiling. Okay, build succeeded. Let's run the tests. Okay, let me command tab. Oh, I can't because it's already done. 0.02 seconds. So that's a lot faster. That's a huge benefit, being able to run these tests without running UI automation testing. The fact that we had coordinators and we're testing coordinators instead of view controllers allows us to do a lot of testing really, really fast, 4,300 times faster. That's great, that's fantastic. Fast testing is its own reward. But there's another huge benefit, and this is arguably a bigger benefit than the speed increase. And that is that these tests, they run in process. I don't need to write special code or conditionally compile code just to examine the state of my objects, right? Because with UI automation testing, my automation tests are run in a separate process. I can't examine the internals of my objects. But when I'm not using UI automation testing, I can. So that's a huge benefit. I found that this is super helpful. So let's summarize. What have we done? We've taken out the view controller and made a lot of the code in the view controller. We've taken that code out and we've made it the responsibility of the coordinator. These coordinators are completely in our control. There's no UI kit magic happening behind the scenes. We can do whatever we want with it. I want to share another really interesting way of using coordinators. What Dave DeLong, formerly of Apple and now with Snap, what he says is you can use UI view controllers as coordinators. That works, but I personally, I don't like doing that. I prefer an explicitly different class, because if other people are writing, or if multiple people are using the same code base, it might be confusing, or it might be easy to abuse, because, hey, I have a view controller. Why can't I just shove everything into one view controller? It comes back to discipline. It comes back to how disciplined are your developers, really. There is one really nice advantage of having a UI view controller, and that is that it's part of the responder chain. So you can take advantage of the responder chain if necessary. Now, having done all of this, let's look back at what we had said we wanted. We wanted distribution responsibilities. We got that. Testability. That was super helpful. Ease of use. I think so. Low maintenance cost as well. And something that's difficult to abuse, because the amount of friction is very low. If the amount of friction is low, it's probably not going to be abused. References. I should have made this all show up on one. There's a video by Sarush Kanlu presenting coordinators. Dave DeLong has an article. All of these URLs are listed in the README in the GitHub repo in the master repository. So Rob Napier had a good talk, learning from our elders. He gave that at a few different conferences. Issue 1 of Objective-C.io, iOS architecture patterns, was a nice article, and then the other one from over here. And with 5 minutes to spare, we're done. Thank you very much. Questions? Any questions?
So coordinators have weak references to their view controllers. If you have a contained view controller inside another view controller, would its coordinator have a weak reference to its contained coordinator?
Okay, I heard that question. That's a great question. So the question was, for the video, the question was, you said that coordinators have, you said that coordinators have weak references to their view controllers. When you have view controllers that contain other view controllers, do their coordinators have weak references back to their respective view controllers? Is that correct? Is that the question that you asked?
Yes.
Yeah, and the answer to that is yes. In general, so yes, by definition, all coordinators will have weak references back to their view controllers, and view controllers will have strong references to their coordinators. Now, I deleted the slide that describes it, but this is actually done in, when you look at the code, you'll see that it's done in that attach method on the coordinator. Either in our prepare for segues or in our handle bio tapped, where we create a view controller and we already have a sub coordinator, we've got the two pieces, the view controller and the coordinator, and then we call attach to attach them, and that attaches the view controller to the coordinator, it attaches the coordinator to the view controller, and all that's done in that one method. And as long as we don't change that method, we don't need to worry about it. They're always connected that way. Does that answer your question?
So my question's, I think, similar, but I'm wondering more for if you have a view controller that contains another view controller. So you have a sub coordinator. Would the sub coordinator have a reference to the first view controller's coordinator? I'm just wondering for passing messages. Like,
So what you're asking is, would the sub coordinator have a reference to the parent coordinator? Is that what you're asking?
Yes, it is. Yeah.
Yeah, and the answer is no. A sub coordinator will not have a reference to its parent coordinator. I can't think of a reason that it should. My guess is that if it does, it probably is an indication that we haven't really thought out the design too well. I like to think of hierarchies as the parent needs to know about the child object, but the child should not know about the parent, because then it is reusable. Now, maybe there are cases where it is necessary and unavoidable, but I can't really think of anything right now.
So if you have a like a segue or something, or if you have some sort of transition that's triggered in the contained view controller by some interaction with an element on the contained view controller, but you want to transition the super view controller, how would that happen?
Okay. So now your question is, if you want to segue from a contained view controller to the super view controller, how would you do that?
I think it's more if you have action on the contained view controller,
yeah,
that would cause, yeah.
Yeah, that makes sense, right? So we have a view controller A that contains view controllers B and C. You tap a button in view controller B, that should cause a segue from A to view controller Z, right? Would you need? That's a good question. I'll have to think about that, because let's see, what would happen over here is that you'd call prepare for segue. What would be the source of the segue? It would be your contained view controller. You would have to invoke, I think what you have to do is you have to call, what's the method to actually invoke a segue? I'm forgetting right now, but you have to basically invoke a segue on the parent view controller. And that parent view controller would already have a reference to its parent coordinator, so that shouldn't be a problem. So even in the case that you're talking about, I don't think that we would need a reference from the child coordinator to the parent coordinator.
Okay.
Yeah, I don't think so.
Okay.
As long as, I do want to say one thing. As long as we're using objects, right? Because objects are copied by reference. If we're using structs in Swift, that's probably not going to work, because if we change the struct, in the child coordinator, that change of the model data, because it's a struct, would not bubble or be visible to the parent coordinator. So we have to pay attention to whether we're using classes or structs. Does that make sense?
Yeah, it does.
Yeah, okay.
Yeah.
What roughly is the ratio that you end up with between the view controllers and the coordinators? And is there any and is it possible to consolidate any of the coordinators?
What's the ratio of classes you end up with between the coordinators and the controllers? And is it possible to collapse some of the coordinators and consolidate them?
Okay, so yes, the question is, what's the ratio between the coordinators and the view controllers? It's possible to collapse some of the coordinators. The question is, can you have a coordinator responsible for multiple controllers? Yeah, I don't see why not. It's a question of, it all comes back to what I was saying about friction and discipline. You have to have that level of comfort knowing that you're okay with where you're taking the architecture, right? There's no reason you can't do that. There's no compiler or preprocessor is going to prevent you from doing that. But yeah, if you have like 6 different view controllers that are pretty much the same, then yeah, you could have different coordinators. I suppose that could be useful if you're doing like, I don't know, maybe doing A/B testing, where half of the users in your app get view controller A to display the screen of text or screen of data. Half of the users get view controller B. You could use the same coordinator. And if view controllers A and B are both in the same app but in different areas of the app, I don't see why we would need to copy the code. So yeah, I would think you could have a non one-to-one relationship. Does that answer your question, Jeff?
Yeah, I was just wondering also, it sounded like you were sometimes putting 3 or 4 coordinators on a view controller, but is it usually just one coordinator?
It sounded like you had cases where you have multiple coordinators on a single controller. Or is it really just one-to-one usually?
It's usually one-to-one. It's usually one-to-one, and but you could have, like I said, you could have one coordinator working with multiple or one coordinator class. Could you? Yeah, you could. You could. Yeah. I haven't really, to be honest, I've got only one app in the App Store right now that uses this. And the other one is obviously this app over here. But the one in the App Store that uses it is a pretty large app, and it's got a one-to-one relationship between coordinators and view controllers. One of the reasons for that is because, at least personally, I'll try not to prematurely factor out code. There's a lot of room for factoring stuff out, but I won't do it unless it's necessary. So right now, there's a one-to-one relationship.
Any more questions? Going once? Going twice? Hey, Jess, that was really a great talk. That was really awesome. Thank you very much.
Thank you very much. I appreciate it. And I hope I can see all of you sometime soon.